In the last video, we introduced formal charge, and I did an example with BRCN to show how that's used to determine which structure of is the most preferred using the formal charge. So in this video, we're just going to work some more examples of calculating the formal charge for each unique atom there. Okay, and so we're going to start with this. So this is good practice for drawing Lewis structures. Phosphorus is down here in group 5, or 15 I should say, so it's 5, and there's one of them, times 5 gives me 5. Chlorine, there's 3 of them, and chlorine is in group 17, so therefore it's 7 to give me 21, so that gives me a total of 26. I draw out phosphorus with 3 chlorines around it. I'm going to go up because space is going to be limited. Cl. So I used up 6 in drawing my structure, so that leaves me 20. And I go 2, 4, 6, 8, 10, 12, 14, 16, 18. So once all my outer ones are full, I still had 2 more left, and they're going to go on the center atom there. So that's my final structure. So now I'm down to 0. Now when I'm calculating formal charge, to save yourself time, all 3 of these chlorines, right up here at the top, all 3 chlorines are identical. And by that, I mean same number of bonds and same lone electrons. So because of that, I don't have to calculate each chlorine. I'm just going to do chlorine once. Okay, so in this example where I have the same, that's fine. If I have one that has a double bond and one that has a single bond, or something's different with the lone electrons, then I have to go through and calculate both of them. So the formula again is formal charge is equal to the valence electrons, so valence electrons, minus 1/2 of the bonding electrons minus the lone electrons. So that's the shorthand version of writing the formula. So the formal charge for the phosphorus, I get the valence electrons. The valence electrons here are simply the numbers written here and here. Okay. So you've already figured out what the valence electrons are. So it's 5 minus 1/2 of the number of bonding electrons. Well, I've got 1, 2, 3 bonds. So 3 times the 2 gives me the 6, minus, and here's a lone electron, which means it's not in a bond, so it has 2 lone electrons. So 5 minus 3 is 1/2 of 6 becomes 3, minus 2 gives me 0. So you do realize that this becomes the same as the number of bonds, but you don't take 1/2 of that. The reason I do it this way is the fact it's simply the way that the book does it. If you just want to count the number of bonds, that's fine. I kind of prefer this method because I'm looking at electrons then for both the bonding and for the lone electrons. But it's your choice. The formal charge of chlorine is 7. Again, that came from the number of valence electrons, minus 1/2. Now, I'm only doing 1 chlorine. Even though I don't have to do them all, I'm only doing 1 chlorine. So it doesn't matter which one I choose. I'm going to look at this one. I'm going to get rid of that line. I'm going to look at this one only. Okay, but so only do it for 1 atom. It didn't matter which one I circled either. Okay, so that 1 atom has 2 electrons because it has the 1 bond. So 1 times the 2. Minus, then it has 2, 4, 6 lone electrons. Okay. And so 7 minus 1 minus 6 is also 0. Okay. So that's the phosphorus trichloride. Now I'm going to go to the perchlorate, and this is an ion here, okay? First I have to draw the structure, so I have chlorine. There's one of them. Let me erase I'll still erase these. All right, so chlorine is down here in group 17, so it's 7. Oxygen, I have 4 of them, times, and oxygen is in group 16, so that's going to be 6. That's 24. That gives me 31. But because of this negative charge here, I have to add a 1. So it gives me 32 total. So chlorine is my central atom, and I have 4 oxygens around it. So I used up 8 doing that, so it takes me back to 24. Okay. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I am out of electrons. Okay. So minus 24 gives me 0. The one thing is that because this is an ion, I have to indicate that by putting a bracket around it and putting the charge outside. Again, each one of these oxygens are identical. In the fact that they all have one bond and 6 lone electrons. So therefore, I'm going to only do it once. Okay? And so this is going to become, I'll do it down here. I'm going to erase something anyway. Formal charge of chlorine is 7, again, from the valence charge up here, minus 1/2 of, it's got 4 bonds, 1, 2, 3, 4, so that's 8 electrons, so the 4 times the 2, minus, and it had no lone electrons, so minus 0. So 7 minus 4 basically is 3. Okay, again, I'm only going to do it for one oxygen. Okay, it doesn't matter which oxygen. 6 is my valence electrons, minus 1/2. And again, I'm only looking at one oxygen. So only looking, let's say this one. It doesn't matter which one I drew a line around. Okay, but that one has one bond, which is 2 electrons. So 1 times the 2, minus, and then it has 1, 2, 3. So that's 6 lone electrons. So in this case, that's 6 minus 1 minus 6, that's a negative 1. Now, I stressed in the last video the fact that the formal charge has to add up to be that of the ion. Okay? And you're going, but I have 3 and I have a negative 1. How does that add up? Well, it's 3 plus, how many oxygens do I have? It's 4. So 4 times a negative 1. And so that's a minus 4. So 3 minus 4 gives me the negative 1 charge that's equal to that up there. Okay? So if you want to take a picture or if you want to pause this video, I need to erase the whole slide so that I can do the last 2. And so 5, 4, 3, 2, 1, erasing. Okay, so we're going to do the SO3 2 minus. Okay, so sulfur, there's one of them, and sulfur is in group 16, so 6 is 6. Oxygen, I have 3 of them. It's also in group 16, so it also has 6. It's 18, so that adds up to be 24, but I have a 2 negative charge, so that's plus 2. Okay, gives me 26. Sulfur is my central atom, so, and I draw 3 oxygens around it. The direction doesn't matter. So I used up 6 to make my bond, and I got 2, 4, 6, 8, 10, 12, 14, 16, 18. That leaves me 20. Okay, minus 18 leaves me 2. So the 2 has to go on the sulfur. Okay, this is an ion, so therefore I have to put a bracket around it to show the fact that it's an ion. Formal charge-wise, the formal charge of the sulfur. So I'm just looking here. Is the 6 from the valence charge minus 1/2. It has 1, 2, 3 bonds, so that's 6 electrons. So the 3 times the 2 minus it has 1 lone electron, so that's lone pair, so that's 2 electrons. So 6 minus 3 minus 2 gives me a positive 1. Okay. And again, I'm going to do the formal charge of just one of the oxygens. Let me erase that because I want to change colors. I like colors. We'll do it in black. Doesn't matter which one of these I choose. All my oxygens are identical. So let's do that one. So the formal charge of the oxygen is still 6. Again, that came from this. Minus 1/2. This oxygen has 1 bond, so it's 2 electrons. Minus, it also has 1, 2, 3 lone pairs, which is 6 electrons. So I have 6 minus 1 is 5, minus 6 is a negative 1. And again, if I do the math, I have 1 plus 3 times the negative 1. Oops. So 1 minus 3 gives me a minus 2. So this adds up to be that. Okay. And for the last one, I have Cl. There's 1. Cl is right here, which is in group 17. So it has 7 valence electrons, is 7. I have bromine, which is 1, also in group 7. Here. So that's 7. So it gives me 14. This is not an ion. There's no charge written afterwards. And it's side by side, so it doesn't really matter. It's 1 chlorine and 1 bromine. I do that by attaching it, so I used up 2, leaving me 12. And then 2, 4, 6, 8, 10, 12. Leaves me 0. There's no central atom anyway. And if I did have more, though, it would go in the bromine because it's the bigger atom. Okay. And so the formal charge of chlorine is going to be 7 minus 1/2 of the 2 minus the 6, 2, 4, 6 gives me 0. I'm going to go over here for the bromide because I get too far down. I get into the things at the bottom. 7 minus 1/2. Again, there's 1 bond, so it gets 2 electrons. Minus, again, it has 2, 4, 6 lone electrons. So that's also 0. And that is the end of this video.